Okay, if we were doing the basic logarithm graph, we know that it's the flip across the line y equals x of the exponential graph because they're inverses. Right? So the graph looks like, now it has the asymptote is here. Right? It has an x-intercept of 1, and the shape of the graph is like that. And we know since they're inverses, the domain of the exponential was all real numbers. That means the range of this one is all real numbers, right? The range of the exponential was y greater than 0. This has to have a domain of x greater than 0. Right? Whether you remember it because of the inverse or whether you just look at the graph and tell that. Domain, x greater than 0, not or equal to, range, all reals. Right? That's just the flip of what we saw in the last one. Okay, now, how does it change this graph? Because we subtracted 1 inside the function. Right 1, right? And when you move to the right, that's going to move the y-intercept, or sorry, the vertical asymptote. It's going to move the x-intercept. Everything moves to the right one. So here's the new intercept, or new asymptote. Here's the graph. Okay, so now this one has the domain. All right, it's no longer x greater than 0. It has to be x greater than 1. It moved 1 to the right. Right, and the range is still all real numbers. Right. And if you just put those in your calculator and thought you could look at it and tell, and then you put down something wrong, and you remember, you got to know more than the calculator about these things, because the calculator, especially with a logarithm, it probably cuts off like right there, and then you don't see anything. It's not because there's nothing there. It's because the calculator has a hard time showing that, and we've said that. So you have to know this much about the log function. Fill it in.